All right, welcome to The Explainer. Today we're digging into something pretty fascinating, a piece of German engineering that's taking on some of Australia's biggest, and I mean most expensive, industrial headaches. Believe it or not, we're talking about a single component that could completely rewrite the rules for maintenance, for safety, and for the bottom line.
So, let's start with a question, a really simple one. How is it that in some of the most advanced industrial plants on the planet, these incredible facilities for mining, desalination, water treatment, how is it that a critical piece of their hardware is still based on tech from the 1800s? Seriously, on the left, that's the problem. It's basically a cage of rusty old threaded rods. And on the right, well, that's the 21st century solution we're going to break down.
So, here's how we're going to tackle this. First, we'll get a feel for what makes Australia's industrial scene so darn expensive. Then, we'll look at why the old way of doing things is just broken. After that, we dive into the smart new solution, the massive time savings it brings, and what it all means for the future of Australian infrastructure.
All right, first things first, let's set the stage. See, to really get why this tech is such a big deal, you have to wrap your head around Australia. It's just a different beast when it comes to industry. There's this thing people call the Australian premium, and what that really means is you've got some of the highest labor costs in the world, mashed together with some of the strictest safety rules you can imagine.
And the biggest piece of that premium? It's the people. The cost of labor is absolutely critical. And I'm not just talking about the paycheck. We're talking about remote sites, right? Think of a mine out in the middle of nowhere. The real cost is everything that goes with it. Flying people in and out, housing them, feeding them, all the special allowances. It all adds up. So literally every single hour a technician is on the job, it comes with this massive price tag.
And check this out. What happens if a job takes longer than planned? The costs just explode. We're talking about a critical piece of machinery, like a giant ship loader at a port or a whole water treatment plant suddenly going offline. When that happens, companies are bleeding hundreds of thousands of dollars for every single hour it's not working. You can just feel the pressure, right? Maintenance has to be fast and it has to be predictable. There's no room for error.
So, you have to ask, where is all this cost and risk coming from? Well, you might be surprised. A huge chunk of it comes down to this one little piece of hardware, the traditional dismantling joint. So what is that? Basically, it's just a special connector in a pipeline. It lets you create a gap so you can pull out a big valve or a pump for repairs. Simple, right? But this is where the trouble starts.
And this is what they look like, the old school design. It's just a mess of long threaded rods sticking out everywhere. I mean, from a safety point of view, it's a nightmare. Your clothes can get snagged on it, you can whack your head on it in a tight space, and worst of all, just look at it. It's a collection of pinch points just waiting to crush a mechanic's hands or fingers. A total liability.
And listen, this isn't just some what-if scenario. In Australia, the work health and safety laws are no joke. There's a core principle called safety by design, which basically means you are legally required to get rid of hazards before they can hurt someone. And get this, if someone gets injured because of unsafe equipment, the liability can go all the way up the chain, right to the company directors themselves.
Okay, so let's connect the dots here. From safety risk right back to that massive cost problem. Think about the Australian environment. It's harsh, it's salty, it's dusty. What do you think happens to all those exposed metal rods? You got it, they rust, they corrode, they seize up solid. So your technician shows up for what should be a simple 1-hour job, but the nuts are frozen. They won't move. The whole job just stops dead. Now they need a hot work permit to get an angle grinder in there to cut the bolts off. That means calling in a second person to stand by for fire watch. And just like that, your 1-hour task has spiraled into 12 hours, or even more. And every single one of those hours is costing a fortune.
So, what's the fix? Well, a German engineering company called ARMARE-TEC looked at this whole mess and took a totally different path. They thought, why are we even trying to make these tie rods better? Let's just get rid of them. So they did. They completely engineered them out of the design, and what they came up with is this patented rodless solution that just eliminates the problem.
And here it is, the Flex Pass. Now, the most important thing to see here is actually what's missing. See that? No long external tie rods, nothing sticking out. The whole system that lets you adjust and lock it is tucked away safely inside. And that one simple, brilliant design change, it solves both the safety nightmare and the massive maintenance delays of the old design in one go.
So let's put them side by side. The old way? It's a minefield of pinch points and hazards. The Flex Pass? The hazard is just gone, engineered right out of it. The old way is a ticking time bomb of rust and seizing. which means your schedule and budget can blow up at any moment. The new way? Maintenance becomes predictable, repeatable. It's even lighter, easier for one person to handle, and it's way more compact, which is a lifesaver when you're working in a cramped space.
And this is the secret sauce right here. This cross-section shows you exactly how they did it. You can see how all the important bits, the locking and sealing parts, are all protected inside the body of the fitting. This means those threads that always used to fail are no longer taking the main force, and more importantly, they're shielded from all that salt and dust. It's just a smarter, tougher design from the ground.
Okay, so we've established it's safer, it's smarter, it's more robust. But let's get down to brass tacks. In that crazy expensive Australian environment, what does all this clever engineering actually get you? The answer is simple. It's all about speed. And here's the headline number, 80%. That's an 80% reduction in how long it takes to install or maintain one of these things. Let that sink in. A job that used to take a crew 4 hours can now be done in less than 1. Now remember those numbers we talked about? When labor costs over $250,000 a year and every hour of downtime costs over 300 grand, saving 80% of your time isn't just nice to have. It's a complete game changer. It's a massive strategic and financial win.
And what's really cool is how this time saving helps literally everyone on the job site. You're the maintenance superintendent under the gun to get a shutdown finished on time. For you, this means getting a critical task done in 45 minutes instead of 4 hours. You're the safety manager? You just eliminated a major cause of injuries right at the source. The project manager trying to keep costs from spiraling out of control? Your total installed cost just dropped. And the principal engineer who has to guarantee these assets will last for decades? You're getting German precision with a 50-year design life. Everyone wins.
But you know, this is bigger than just swapping out an old part for a new one. This is really about building smarter, tougher, and safer infrastructure for the future. We're talking about Australia's most critical industries here.
And the potential uses are just huge. Think about it. In the mining sector, it's perfect for handling all that gritty, corrosive stuff. For cities and towns, it means they can upgrade their aging water pipes way faster. For desalination plants, it's a no-brainer. It's built to handle that high-pressure, salty environment. And looking ahead, its super reliable seal makes it perfect for the new world of green hydrogen. It's incredibly versatile. Now, for the people who manage these giant assets and have to think 50 years into the future, this changes everything financially. They have this concept called TOTEX, which stands for total expenditure. It's a fancy way of saying you have to look at the entire cost of something, not just the price you pay today. So yeah, the FlexPass might cost a bit more upfront. That's your CapEx. But because it slashes maintenance time and breaks down less, it dramatically cuts your long-term running costs. That's your OpEx. When you add it all up, the true total cost of owning it over its lifetime is way, way lower.
So when you're in a place where every minute of downtime costs a fortune and where the safety of your people is literally in the hands of the company directors, can you really afford not to look at this stuff differently? The big takeaway here is that you have to stop looking at the sticker price. You have to look at the total cost to get it installed, its long-term reliability, and the impact it has on safety. When you do that, this stops being just a piece of pipe, and it becomes a powerful strategic tool. It really proves that in these high-stakes games, the smartest engineering is about changing the entire equation of cost, risk, and time.